First of all, a very good morning to all of you. So today we are going to start a new topic, that is internet evolution, and we will see that what internet is, how it came to being, its history, present day scenario, and where it is heading towards. So let's start. So this word internet, it can be divided into two parts. One is inter and second is net. So inter means among. You must have heard inter-school competition or inter-house competition. It means that competition is among schools, yeah, or among houses. So inter means among. Now net here means network. So what is a network? A network means group of interconnected computers or nodes. We are saying computers because we are dealing with computer science. So nodes here we can say computers instead of nodes. So a network is a interconnected computers which interacts with each other, and that thing we call a network. Now one may ask that what is the need of a network, why there is a network. So the main need of a network is resource sharing. We can share different resources with the help of a network. Suppose there is a lab and we have a network, and we have only one printer with us. So if we can connect that printer with that network, so all the computers in that network can use that printer, of course, one at a time. So the main objective which is fulfilled here is resource sharing, and that resource can be a hardware or a file or anything. So I hope the need of a network is clear, that why we need a network. Now internet means network of networks. So we will explain this definition. We will understand this definition once we go through this slide, and I'm sure that you all will understand it very well, that why internet is called a network of networks. So first let's dive deep into the history of internet, from where it came, why it came. So let's start. Now this starts with the end of World War II. Two superpowers, that were Russia, Soviet Union and America. They were in cold. They were in a state of Cold War after World War One, and they were striving for the supremacy in space travel. And America was stunned when USSR uh, launched their first ever man-made satellite, Sputnik 1, in October 1957 into space. That shook America. Uh, it was in the October of 1957 that this thing happened. And there is a very famous Hollywood movie called October Sky, based upon this. Very nice movie. One can watch that. So basically, this USSR defeated America in this space race, since they launched the world's first man-made satellite into space. Now this thing, mm, this hurt, this thing hurt America. Why? Because they thought that they were the world leader, and how can they be defeated by a country which they thought was not up to their status. So what was their response? This American Department of Defense, that we call DoD, in response to USSR's this space race, what they did, they formed a committee, or I should say a agency within their department, and that agency was called ARPA, that was Advanced Research Project Agency. And this ARPA, what it did, it formed a network for the defense, for the Department of Defense of US, and they called this network ARPANET. It was basically for the defense people and the Department of Defense of US. Now since this ARPANET was basically for the defense, others were later allowed to join in. Now others means these universities and private sector players, they were later allowed to join in it. And apart from this ARPA, there was this agency called this National Science Foundation, NSF. They formed their own private network, that was NSF Net, and later they collaborated with ARPANET and became their backbone. So now this NSF Net and ARPANET, and they were connected. And many other private players like this IBM and many other big companies, they form their own private network. And later on, all these networks, they got interconnected among themselves, and hence this term internet came. So internet was a network of networks. This ARPANET, NSF Net, and other private networks, when they joined among themselves, so they formed this internet, and hence we say that internet is a network of networks. I hope now this definition, internet, why it is called network of networks, is clear to you. So now you have seen that from ARPANET to internet, how this thing evolved. Now there is another term that we are using today, is interspace. Now what is this interspace? Interspace is a software. It's a client server software, or we can say that it is something which internet is bound to become. It means what? It means internet, this interspace is the future of internet. So going by the definition of interspace, we can say that interspace is a software that allows multiple users in a client server environment to communicate with each other, to send and receive data of various types, such as data files, video, audio, textual data, or any other data in real time, very fast, and it gives you realistic experience. So this interspace, we can say it's the future of internet. I hope this term interspace is clear. It is nothing but this speed that we will achieve in few years, that 5G is coming. So this experience of internet, it will get enhanced, and the way we receive data from this the internet, it will change. We will have some realistic experiences with the internet, and that's why we are calling it interspace, that thing. I hope it is clear that what is interspace. So this ARPANET, internet, and interspace, these terms must be clear to you. Now let's move ahead and see that how data is transferred between nodes. So here we can say computers, how data is transferred between computers in a network. So there is a term called switching. It means what? It means it is a mechanism for moving information between different networks. So suppose there is a node here and there is a node here. So if you want to send data from A to B, it might go from here, then to here, then here, and then here, and then here to reach. So it will go through different nodes in between, and then it will reach B. So this mechanism is called switching. And there are mainly 3 types of switching that you have to study, because it's in the syllabus and we are going to see that. Um, switching can be divided into three parts, as I've said that the types are circuit switching, message switching, and packet switching. So these are the three types of switching techniques that we use. In fact, circuit switching is an old technique that we don't use today, but we have to study because once it was a major switching technology, this circuit switching. And we will see the difference between circuit, message, and packet switching in the coming slides. So let's start. So first, circuit switching. Now what is circuit switching? In circuit switching, when two nodes communicate with each other, they do it over a dedicated communication path. It means first there a path will be created, and then the communication will happen only over that path. So there is a need for a pre-specified route from which the data will travel, and no other data will travel anywhere. I hope this thing is clear. It means in circuit switching we need a pre-specified route. So that is the keyword, pre-specified route. We need a pre-specified route, and all the data will go through only that route. So here it is also written that in circuit switching, a dedicated channel or circuit is being set up for a single connection between sender and recipient during the communication session. No other route can be followed. And one thing more, that once the connection is established between two parties, it will be available till the end of the conversation. What does it mean? It means that no other being can use that communication channel, that is being reserved. Earlier phone calls used to be like this. First there is a dedicated link between two people who needs to talk, and then once that link is established, then only they can talk. So the last point here, it is written that the channel is reserved, and that's what I was saying, between the users till the connection is active. I hope that this circuit switching is clear to you. So few keywords that you have to remember in circuit switching is, first, that before a communication begins there has to be a pre-specified route for that, and once that route is there, the connection is established and data will flow through that specified channel or connection, and that is being reserved for the communication. I hope this thing is clear to you. Now as I was giving you example of a telephone system, so here it is also written that in a telephone communication system, the normal voice call is the example of circuit switching. That's exactly I was saying. The telephone service provider maintains a unbroken link for each telephone call. And so here we can see that applications which use circuit switching may have to go through three phases, and we have already gone through those three things. First, establish a circuit, first point. Second, transfer the data, and third is disconnect the circuit. So I hope it's clear. Now some advantages and some disadvantages of circuit switching. Of course, advantages is that there is a dedicated path established between the sender and receiver. There is no competition. Once that path is established, the parties, they don't have to bother that whether they will get the bandwidth or not. It is for them now. Second, that data is transmitted without any delay. Of course, when there is no competition, once the connection is established, there is no delay in the transmission, or there is no waiting time or things like that. And the third one is, since a dedicated continuous transmission path is established, the method is suitable for a long continuous transmission. if you want to send a long data or something very big, so this circuit switching is suitable for that. Now we are going to discuss certain disadvantages of circuit switching. First, that as the connection is dedicated, it cannot be used to transmit any other data. Yes, it cannot be used to transmit any other data. Second, in terms of efficiency, I think it's inefficient, and it is inefficient in terms of utilization of system resources. Of course, when only two parties can have the access to that link, it means there is a waste of resource. So, or we can say full utilization of resource is not taking place in circuit switching, and that can be a disadvantage. Third point, dedicated channel requires more bandwidth, of course. And the fourth point is that prior to actual data transfer, the time required to establish a physical link between the two stations is too long. Yes, because in circuit switching we have to establish a connection prior to communication. So there is a time for that. Means it takes time to establish a connection. So that is also one major disadvantages of circuit switching. Now coming to message switching, the second type of switching. So in this type of switching, there is no need to establish a dedicated path between sender and receiver. In circuit switching, we used to establish a path first, and then any data transfer used to happen. But in this, we don't have to establish a dedicated path between the transmitter and receiver. Okay. So what happens in message switching is that along with the message or the data, the address destination is appended to the message. Of course, if there is no dedicated path, the message itself has to contain the address that where it has to go. So this thing happens in message switching. Now for sending the message, the intermediary nodes, they are responsible for switching they are responsible for sending or forwarding the data, and the message is transmitted as a whole from source node to destination node. And one very important thing that you have to understand is that this message will go from here to here. Now this node, it will store this message, and after storing, it will forward this message to this second node, and this node will do the same thing. Okay, so first entire message has to be passed from this node to this node, and then that entire message has to be passed from this node to this node. So it is also called store and forward network type. Okay, so this type of network which uses message switching, it is called store and forward, because message is first stored and then it is forwarded. Okay, so I hope this message switching is clear to you. So the main thing that you have to remember, the keywords that you have to remember is: first, no need to establish a dedicated path, first point. Second point, store and forward technique is used in message switching. Okay, and this message switching is not recommended for real-time application, of course, because they are using this store and forward technique, so it can cause delay. Now this is the diagram you can draw in examination. If they ask that what is message switching, of course you have to write those two important points. That first is there is no need to establish a dedicated link first, and second, that it uses store and forward technique. So I hope this thing is clear. This is also a diagram for message switching, but this is easier one, so you can draw this thing. Now advantages and disadvantages of message switching. First, the advantages: the efficiency can be greater compared to circuit switching because more devices are sharing the channel because there is no dedicated link, so many can share the channel. Okay. Second, traffic congestion can be reduced because messages may be temporarily stored in a route. uh, so I think this point is very clear to you now, because store and forward technique is used. So if there is a congestion, one node can stop transmitting that data, or it can keep that message with it for a time being and then forward it after there is no congestion. Okay. And third point, message priorities can be established due to stored and forward technique. Of course, we can set priorities. Now, disadvantages. First is that message switching is not compatible with interactive application. With the interactive application, we cannot use message switching because of the time delay and lag. Second, store and forward technique is expensive because nodes need to have large disk to hold the data. Third point, it is slow because of store and forward technique. I think it's clear. And last one is that it is not recommended for real-time application. We have already discussed. So that was about message switching. Now coming back to packet switching. Now packet switching is major switching technique which modern internet uses. Now in packet switching, messages are divided into smaller pieces called packets. Now what happens is that, suppose this is a message. So this message will be divided into smaller things, and these things are called packets. And these packets, each one of them, it stores the source, destination and intermediate node address with it. And in packet switching, it is easier for intermediate networking devices to store small size packets, and they do not take much resources either on carrier path or in the internal memory of switches. So in packet switching, we do not need a predefined dedicated path, and these all packets, they do not need to follow the same path. What does it mean? It means कि suppose one packet follows this path to reach from A to B, another packet, this one, it can follow this path. So there is no foundation on packets to follow a particular path in packet switching. So I hope this packet switching is clear to you. The main keywords are, or the key points are, that messages are divided into smaller pieces called packets, and there is no predefined dedicated path, and messages, these packets, they do not, all the packets, they do not follow the same path. They are independent, in their going from A to B in this case. So I hope this packet switching is clear to you. Now just comparing all the three switching techniques, that is circuit, message and packet switching. So the first point is that in circuit switching, there is a physical connection between transmitter and receiver, and in message and packet switching, there is no physical connection between the transmitter and the receiver. Second point, that all packets follow the same path in circuit switching, but it does not in message and packet switching. In message switching, we have packets are stored and forwarded. Whole message is first stored in a intermediate node, and then it is forwarded to the other node. And in packet switching, packets travel independently, as we all know. Now the third point, we need an end-to-end path before data transmission. This thing we all know. And in message switching, there is no need of end-to-end path before data transmission, and same thing goes with packet switching. Circuit switching reserves the entire bandwidth, and message and packet switching does not do this. There is a waste of bandwidth in circuit switching, and no such thing happens in message and packet switching. And Circuit switching cannot, of course, it cannot support stored and forward technique, and these two, message and packet, they support stored and forward transmission. And in circuit switching, it is not suitable for handling interactive traffic, and so is message switching. It is not, here not is missing, it's not suitable for handling interactive traffic, but packet switching is capable of handling interactive traffic. So I hope this topic, internet evolution and this switching techniques, it is now clear to you. So that's all for today. Thank you.